Now we'll discuss JEE Advanced 2023 Mathematics Paper 2. Now in this question we are given a differentiable function f such that f1 is 1 by 3 and we are given this integral equation which is 3 times this integral from 1 to x ft dt and it is equal to x fx minus x cubed by 3 for all x greater than or equal to 1. Now we need to find the value of fe. Now since it is an integral equation with variable limits, we know we have to use Newton-Leibniz formula. So we'll differentiate this function. So we can write this is 3 and here will be this fx, derivative of x is 1 minus derivative of 1 is constant and here it is x f dash x plus fx and this is minus x square. We can write this as x f dash x minus 2fx and this is equal to x square or f dash x minus 2 upon x fx and it is equal to x. Now basically this is linear in y. So this is dy by dx minus 2 by x y and this is x. Now linear in y, it is simple. First we need to find its integrating factor. Now its integrating factor will be e to the power integral of minus 2 upon x dx. So that will be e to the power minus 2 ln x, so which is x to the power minus 2. So it will be 1 by x square and then we'll write its solution. So it will be y into 1 by x square into this integral 1 by x square into x dx. Now this x and x will cancel. So we'll get this as y upon x square and it will be equal to ln x plus c. Now we are given that when x is 1, y is 1 by 3. So if we put x as 1 and y is 1 by 3, so this is 1 by 3 log 1 0 plus c, value of c is 1 by 3. So we'll replace this c with 1 by 3. So basically we'll have y equals x square log x plus 1 by 3 x square. Now we need to find the value of fe. Now fe is basically when the value of x is e. So there will be e square ln e is 1 and this is e square by 3. So this value is 4 e square by 3 and that's your option C. Now the question is, consider an experiment of tossing a coin repeatedly until the outcome of 2 consecutive tosses are same. If the probability of random toss resulting in heads is 1 by 3, then probability that experiment stops with head is. Now for this particular coin, probability of getting a heads, it is 1 by 3 and probability of getting a tail, it is 2 by 3. Now we need to find this probability that the experiment stops with head. Now terminate in heads if you have 2 consecutive heads before 2 consecutive T's. So this first case could be when the first toss itself, it results in heads. So it will be this head head, or it could be head tail and then 2 heads, or it could be head tail and then 2 heads, and this series will continue up to infinite. So it is an infinite geometric progression. So here in this case, this is 1 by 3 square and here it is 2 by 3 to the power 4 and here it is 2 square 3 to the power 6 up to infinite. So if we calculate this sum, or this part of probability P1, it will be 1 by 3 square A upon 1 minus R, which is 2 upon 3 square, and this probability will be 1 upon 9 minus 2, 7. So this probability is 1 by 7. So that's your first case. Now for this second case, when the first toss results in tail. So it is tail, head, head, or it could be tail, head, tail, head, head, or tail, head, tail, head, tail, head, head. I'll continue up to infinite. Now this is 2 upon 3 cube, and say this is second part of the probability P2. This is 2 square upon 3 to the power 5. This is 2 cube upon 3 to the power 7 up to infinite, which again is an infinite GP. So this is 2 upon 3 cube upon 1 minus, and common ratio here is 2 upon 3 square. So this is 2 upon 3, and this is 7. So it will be 2 by 21. So this required probability will be 1 by 7 plus 2 by 21, which is 5 by 21, and that's your option B. And question number 3, we are given cot inverse y in its principal value range 0 to pi, and tan inverse y in its principal value range from minus pi by 2 to plus pi by 2. Then sum of all the solutions of this equation for mod y lying between 0 to 3 is. Now essentially we are given tan inverse 6y upon 9 minus y square plus cot inverse 9 minus y square upon 6y, and this is equal to 2 pi by 3, and we are given that mod y lies between 0 to 3. Now this 9 minus y square will always be positive, but we have this y, and this y, it can be positive or it can be negative. So what we'll do is we'll solve this question in two parts. We'll take up this first case when y is positive. So when y lies between 0 to 3. Now this is tan inverse 6y upon 9 minus y square plus, now since this is a positive number, it will be tan inverse 6y upon 9 minus y square, and that is equal to 2 pi by 3. Now we can also write this as 2 times tan inverse, and we'll divide everything with 9. So there will be 2 y by 3 and 1 minus y by 3 whole square, and that is equal to 2 pi by 3. Now this 2 and 2 will cancel. Since y by 3 lies between 0 and 1, and if we take y by 3 as tan theta, it becomes tan to theta and its principal range. So it will be this 2 tan inverse y by 3, and this is equal to pi by 3, or tan inverse y by 3, it is equal to pi by 6. We have done all that in our inverse trigonometry playlist in depth. Now this is y by 3 and tan pi by 6 is 1 by root 3. So from here we'll get value of y as root 3. So one of the solution is value of y is root 3 when y lies between 0 and 3. Now we'll take up the second case when y lies between minus 3 and 0. So we have Our second case, when y lies between -3 and 0. So now we have tan inverse 6y upon 1 minus y square plus cot inverse upon 9 minus y square plus cot inverse 9 minus y square upon 6y, and this is equal to 2 pi by 3. Now we know that cot inverse minus x is pi minus cot inverse of x. So it will be tan inverse 6y upon 9 minus y square, and this is pi minus, and this is cot inverse y square minus 9 upon 6y, and this is equal to 2 pi by 3. Now since this is positive, we can take the reciprocal and make it 10, and if we take minus sign common, so we can actually write this as 2 tan inverse 6y upon 9 minus y square, and this is 2 pi by 3 minus pi, and there will be minus pi by 3, or we can write 6y upon 9 minus y square, there will be 10 minus 10 pi by 6, there will be minus 1 by root 3. So we can write this as y square minus 9, and this is equal to 6 root 3y, or y square minus 6 root 3y minus 9 equals 0. Now here we'll get solution as minus b 6 root 3 plus minus under root of b square. Now this is 36 into 3, 108 plus 36 divided by 2. 144 is 12. So there will be 6 root 3 plus minus 12 divided by 2, which is 3 root 3 plus minus 6. Now since we need y in this region between minus 3 and 0, the only value of y which we are going to choose is y equals 3 root 3 minus 6. So now we have both the solutions. Now what it is asking for is sum of all the solutions of this equation. So sum of all the solutions of this equation will be simply root 3 plus 3 root 3 minus 6, and there will be simply 4 root 3 minus 6, and that's your option C. Now question number 4 is a very straightforward question. It says we are given 4 points P, Q, R, S, and we have to find which of the following statements is true. So first one is the points P, Q, R, S are not coplanar. For that what we'll do is we'll find PQ, PR and PS. Now PQ is B minus A, so there will be 2i plus 4j plus 8k. Now PR is C minus A, and there will be 12i by 5 plus 6j by 5 plus 12k, and PS will be I minus j plus 6k. If they are coplanar, their determinant is 0. So all we need to check is whether this determinant, it is 0 or non-zero. Now here we'll take 2 common. So we can write 1, 2, 4. For the second row, we'll take 6 by 5 common. So here will be this 2, 1 and 10, and here it is 1 minus 1 or 6. Now what we'll do is we'll write R2 as R2 minus R1 minus R3. So there'll be 12 by 5. Now this is 1, 2, 4. Now this is 2 minus 2, 0. 1 minus 1, 0. And 10 minus 10, 0. And this is 1 minus 1, 6. And this is equal to 0. So basically points P, Q, R, S are actually coplanar. So that means this option A, it is incorrect. Now next it says B plus 2D upon 3 is a position vector which divides PR in this ratio 5:5. We have to find whether it is internally or externally. Now we'll take P and R. Now P is given as this vector A, which is I plus 2j minus 5k, and R is 17 by 5i plus 16 by 5j plus 7k, and we'll also find B plus 2D upon 3. Now B plus 2D upon 3, it will be, this is 3i plus 4, 7. So there'll be 7i, and then 6 plus 2, 8j, and then 3 plus 2, 5k, whole divided by 3. So we have this point 7i plus 8j plus 5k by 3, and we have to find in what ratio it divides PR. Now if we just check its x coordinate, we can write 17 by 5 lambda plus 1 upon lambda plus 1, and that will be equal to 7 by 3. So it will be 17 lambda plus 5 upon 5 lambda plus 5, and this is 7 by 3. Now this is 51 lambda plus 15, 35 lambda plus 35. Now this is 16 lambda, and it will be equal to 20. So value of lambda is 5:4, and this value is positive. So it divides PR in the ratio 5:4 internally. Now the proper way of solving this question is to check whether we get the same ratio for J and K. Since it is single option correct, we know this C is definitely incorrect, and B, it could be right. Now D is square of magnitude of vector B cross D is. Now if we find B cross D, B cross D is this I, J, K, B is 3, 6, 3, and D is 2, 1, 1. Now here we'll take 3 common. So here we'll have 1, 2, and 1. So B cross D will be 3, and this is I plus j minus 3k. Now mod of b cross d, that will be equal to 3, and this is 9 root 11. So mod of b cross d square, that will be equal to 99 and not 95. That means definitely this option B is correct. Now in question number 5, we have given this matrix AI such that Aij is 1 if j plus 1 is divisible by I, otherwise Aij is 0, and it's a 3 cross 3 matrix. So first we want to create this matrix M, which is a 3 cross 3 matrix. Now when the value of I is 1, it is going to divide every value of j plus 1. So all these 3 entries, they'll be 1. Now when I is 2, j plus 1, it should be divisible by 2. That means j has to be odd. So it'll be this 1 and 1 here and 0 here. And for this third case, when I is 3, the only possible case is when j is 2. So it'll be 0, 1, 0. So that's your M. Now first question is M is invertible. Now we find determinant of M will be 0. So basically M is not invertible. So this option 8 is incorrect. Now if M is 0 and we have this equation Mx equals to 0, it is homogeneous equation. When it is homogeneous equation, in that case, if determinant is 0, we'll have non-trivial solution. That means it'll have infinitely many solutions. So we'll get many x which are non-zero. So that means this option C, it is correct. Now if we look at this option B, we are given mx equals minus x. Now here we can write m plus I, x equals 0. Now if we look at m plus I, this matrix m plus I, it will be 2, 1, 1, 1, 1, 1, and then 0, 1, 1. Now if we find determinant of m plus I, again we have two columns same. So this is 0. So again this is homogeneous equation where delta is 0. So again it will have non-trivial solution. And because it has non-trivial solution, there exists non-zero column matrix such that mx equals minus x. So that means this option B is also correct. Now option D is matrix M minus 2I is invertible where I is 3 cross 3 identity matrix. Now we need to find M minus 2I. Now M minus 2I is minus 1, minus 2, minus 2, and this is 1, 1, and this is 1, 1, and this is 0, 1. Now we have to find its determinant, and what we'll do is we'll write R1 as R1 plus R2 plus R3. Now this is 0, this is 0, and this is 0. So basically this is 0. So this matrix M minus 2I is non-invertible. So that means this option D is incorrect. So the correct options are B and C. Now in question number 6, we are given this function f which is defined on 0 to 1, and we have defined this function as fx equals greatest integral function of 4x, and this is x minus 1 by 4 square into x minus 1 by 2. Now this is defined between 0 to 1. Now when x is defined between 0 to 1, 4x is defined between 0 to 4. So what we'll do is we have to split this definition in 4 parts. First case, when x lies between 0 to 1 by 4. Second case, when x lies between 1 by 4 and 1 by 2. Next is from 1 by 2 to 3 by 4, and then from 3 by 4 to 1. So we have to expand this definition. When x lies between 0 to 1 by 4, 4x lies between 0 to 1. So this is 0. So this function will have this value as 0. Now between 1 by 4 and 1 by 2, 4x will lie between 1 and 2. So this value will be 1. So simply it will be this x minus 1 by 4 square into x minus 1 by 2. Now here if you multiply with 4, it will lie between 2 and 3. So there will be 2 times x minus 1 by 4 square into x minus 1 by 2, and here it will be 3 times x minus 1 by 4 square into x minus 1 by 2. So this is our function. Now first we'll check its continuity. Now f 1 by 4 negative, it is 0, and f 1 by 4 positive. If we put x as 1 by 4 here, this is 0, so it is continuous at 1 by 4. Now we'll check its continuity at 1 by 2. So f 1 by 2 negative. Now f 1 by 2 negative, this is 0, and f 1 by 2 positive. Now here in this case, again it will be 0. And since it is a continuous function, we can use equality sign anywhere. Now what about at 3 by 4? Now at 3 by 4, f 3 by 4 negative, it will be 2 into 3 by 4 minus 1 by 4. That will be 1 by 2 square, and here it is 3 by 4 minus 1 by 2, and that will be 1 by 4. So it will be simply 2 by 16. Whereas f 3 by 4 positive, there will be 3 by 16. So this function is discontinuous at 3 by 4. So this function fx discontinuous at x equals 3 by 4. So this function is discontinuous exactly at one point on 0 to 1. So that means this option A is correct. Now let us look at its differentiability. Now at 1 by 4 it is continuous, and if we check its left hand derivative, so f dash 1 by 4 negative, it is 0, and if we look at its right hand derivative also, f dash 1 by 4 positive, since it is square here, so once we have to differentiate it, every factor will have x minus 1 by 4, and if you put x as 1 by 4, it will be 0. So this function, it is differentiable at 1 by 4. Now what about 1 by 2? Now if we differentiate this function, if we find f dash x with say some constant c, so we write fx as some c x minus 1 by 4 square into x minus 1 by 2, and if we differentiate this function, we can write f dash x as c into x minus 1 by 4 whole square plus x minus 1 by 4 into x minus 1 by 2 into 2. Now we can take x minus 1 by 4 common, so there will be c, and this is x minus 1 by 4, and here we'll have x minus 1 by 4 plus 2x minus 1, so there will be x minus 1 by 4, and this is 3x minus 5 by 4. If we put the value 1 by 2, so at 1 by 2, this is non-zero, so we'll get this value as some k. Now on the left hand side, the c is 1, and on the right hand side, the c is 2. So here, this f dash 1 by 2 negative, it is not equal to f dash 1 by 2 positive. So at 1 by 2, this function is continuous. So at 1 by 2, this function is continuous, but this function is not differentiable. And at 3 by 4, it is discontinuous. And since it is discontinuous, it is also not differentiable. So we'll come back to it. So option B is, there is exactly one point at which function is continuous but not differentiable. So that one point is 1 by 2. So at 1 by 2, this function is continuous but not differentiable. And C is, function f is not differentiable at more than 3 points. Now that's not true. It is not differentiable only at 1 by 2 and 3 by 4. So option C is incorrect. And the next one is, minimum value of this function is minus 1 upon 512. Now, if we look at this function, you already differentiated it. Now its critical points are 1 by 4 and 5 by 12. Now this is plus, minus and plus. So its minimum value will come at 5 by 12. And 5 by 12 is nearly 0.41. Which will be in this interval. Now we need to calculate its value. So we need to find f 5 by 12 and it will be in this interval. So it will be 5 by 12 minus 1 by 4 square and then 5 by 12 minus 1 by 2. Now this is 3, 2 by 12, 1 by 6. So there will be 1 by 36 and this is 6 by 12 and there will be minus 1 by 12 and this is minus 1 upon 432. So its minimum value is minus 1 upon 432 and not minus 1 upon 512. Option D is incorrect. Now in this question it says, let S be a set of all twice differentiable functions from R to R such that f double dash x is greater than 0. Now it simply means that this graph is going to be concave up. Now it says for all x belongs to minus 1 to 1, for function belonging to this S, xf is number of points in this interval where fx is equal to x. Then which of the following statements is or are true? So basically what we'll do is we'll draw our axis and then we have 2 points minus 1 and 1 and we'll draw y is equal to x line. So this is our y is equal to x line and then we have so many functions which are concave up. Now in this set there will be functions where these two they'll never intersect, in which case value of fx will be 0. So there exists a function f belongs to S such that fx is equal to 0. This is true. So that means this option A is correct. C is there exists a function such that xf equals to. Now we can take a function which can be drawn like this, where we'll have 2 points of intersections. So xf can take the value 2. So that means this option C is also correct. And then we can also have this function f, where this curve, it just touches this line. And in that case, value of xf will be simply 1. So xf can take the value 0, 1 and 2. So option B is correct. xf is always less than or equal to 2. And option D is there does not exist any function such that xf equal to 1. Now this is incorrect, because we can have a function which can just touch this line in this interval. So option D is incorrect. So the correct options are A, B and C. Now for question number 8, we are given tan inverse x in its principal value range, and it says we need to find minimum value of this function fx, which is given by this integral from 0 to x tan inverse x, and this is e to the power t minus cos t upon 1 plus t to the power 2023 dt. Now if we find f dash x will be e to the power x tan inverse x minus cos of x tan inverse x upon 1 plus x tan inverse x to the power 2023 into derivative of upper limit. Now this is x as it is, and this is 1 upon 1 plus x square and plus tan inverse x as it is, x is 1. Now what we'll do is we'll put it equals to 0. Now exponential function, it is always positive. Now this x tan inverse x will always be non-negative. This expression also will be positive. Now the only expression that changes sign is this one. Now when x is less than 0, so f dash 0 negative will be less than 0, and f dash 0 positive, it will be greater than 0, and f dash 0 is 0. So here the critical point is 0, rightmost is plus, and this is minus. So we have a point of minima at x equal to 0. So minimum value of this function is given at x equal to 0. So f0 will be this limit from 0 to 0 tan inverse 0 is 0 e to the power t minus cos t upon 1 plus t to the power 2023 dt. Now integral from 0 to 0 is 0. So minimum value of this function will be simply 0, and that is the answer to this question. Now here the question is, let yx be the solution of this differential equation and such that y2 is 7, then find the maximum value of this function yx. Now we are given that x square minus 5 dy by dx minus 2xy, and is minus 2x into x square minus 5 whole square. Now what we'll do is we'll divide everything with x square minus 5. So it'll be this dy by dx and then minus 2x upon x square minus 5y, and here it will be minus 2x into x square minus 5. Now this is linear in y. Linear differential equation in variable y. Now first we'll find its integrating factor. So its integrating factor will be e to the power integral of minus 2x upon x square minus 5 dx. Now if we take this as t, it will be dt. So it will be e to the power minus 1 upon t. There will be log 1 by t, and e and log will cancel. So it will be simply 1 upon x square minus 5. So integrative factor will be 1 upon x square minus 5. Now this is y into 1 upon x square minus 5, and it will be equal to this integral 1 upon x square minus 5 into minus 2x x square minus 5 dx. Now I'll cancel. So y upon x square minus 5, this is minus x square plus c. Now when x is 2, y is 7. So this is 7 and this is minus 1 and this is minus 4 plus c. So value of c is minus 3. So this y, it will be x square minus 5 into minus x square minus 3, or we can write this as y equals x square plus 3 into 5 minus x square. Now rather than solving it in x square, what we'll do is we'll write this as y equals t plus 3 into 5 minus t, where t is greater than or equal to 0. Now we know that it is a parabola opening downwards. Its maximum value will occur at midpoint of roots. So here critical points are minus 3 and 5, and its midpoint or critical value of t, it will be simply 1. So maximum value of y, it will be when the value of t is 1, and if the value of t is 1, so this is 4 into 4, and it will be simply 16. So answer to this question is 16. Now here the question is, let x be set of all 5-digit numbers formed using digits 1, 2, 2, 2, 4, 4, 0. Now suppose that each element of x has an equal chance of being chosen, and let p be conditional probability that an element chosen at random is a multiple of 20 given that it is a multiple of 5. So we have two events. A, it is a multiple of 20. B, given that it is a multiple of 5, we have to find this conditional probability of A by B, which is probability of intersection B upon probability of B. Now this 5-digit number, it will be a multiple of 5 if and only if last digit is 0. So we have this 5-digit number and we have 0 at the end. And what we are left with is 3 2s, 2 4s, and 1 1. Now these 4 numbers, they can be 3 alike, 1 distinct. So it could be 2 2 2, and the 4th number, it could be either 4 or 1. So this is one case. Second case could be, it could be 2 alike, 2 alike. So 2 2 4 4. Third case could be, it is 2 alike and 2 distinct. So either it is 2 2 4 1 or it is 4, 4, 2, 1. So these are the 4 cases possible. Now in this first case, we have to choose any one of 4 or 1. So it can be done in 2 C1 ways. Now we have 3 alike, 1 distinct, and it can be arranged in factorial 4 divided by factorial 3 ways, and there will be total 8 ways. And then we have 2 2's and 2 4's. We can arrange it in factorial 4 divided by factorial 2, which is 6 ways. 2 2 4 1 factorial 4 divided by factorial 2, which is 12, and here also will be factorial 4 divided by factorial 2, and this again is 12. So this is 38 cases altogether. So we have altogether 38 cases. Now it says we need to find this probability that the number is a multiple of 20 when it is given that it is a multiple of 5. Now it will be a multiple of 20 when it is a multiple of 5 and it is also a multiple of 4. So for this we need this additional condition. It should be a multiple of 4. Now what we'll do is we'll do it using elimination. So we'll find those numbers which are not a multiple of 20. So among these 38 numbers, we are going to find all the numbers which are not a multiple of 20. Now, how many such numbers are there? Now, if we look at this first case, if it is 20 or 40, then it will be divisible by 4. So here it has to be 10. So it will be 10, and then we are left with 2, 2, 2. So there is this only one case. Now for this second one, it is 2 or 4. So it will be 20 or 40. So here we are not going to get any case. Now for this third one, again we should have 1 0. So we have 1 0. And then we have to arrange 2, 2, 4. It can be done in factorial 3 divided by factorial 2. 3 ways. And then this fourth case, again when this is 1 0, so again it will be this 3. So altogether there will be 7 cases out of 38 where number is not a multiple of 20. So this number will be a multiple of 20 in 38 minus 7 cases. There will be in 31 cases, and this required probability will be simply 31 by 38, and it says this probability is P. Now we need to find the value of 38P. So value of 38P is simply 31, and that is the answer to this question. Now here the question is, let A1, A2, A3 up to A8 be vertices of regular octagon lying on a circle of radius 2. Let P be point on a circle, and let PA1, PAI denote the distance between the points PAI for I equals 1 to 8. If P varies over the circle, then the maximum value of this product PA1, PA2 and PA8 is. Now basically what we'll do is we'll draw a circle of radius 2 units and we're going to draw an octagon. So let this be O and radius is 2 units, and all these angles, they are simply 2 pi by 8, which is pi by 4. Now what we'll do is here we're going to use nth root of unity, or basically 8th root of unity. So 8th root of unity there will be 1 alpha square and alpha to the power 7. But here in this case, value of r is 2. So what we'll do is we'll take roots as 2 alpha square and 2 alpha to the power 7. So without loss of generality, we'll arrange these numbers a1, a2, a3, a8 along these roots. So this is your a1, that's your a2, a3, a4, a5, a6, a7, and this is a8. So basically they are roots of this equation, z to the power 8 minus 2 to the power 8 equals 0, or we can write this as z to the power 8 minus 2 to the power 8 will be equal to z minus 2, z minus 2 alpha, z minus 2 alpha square up to z minus 2 alpha to the power 7. Now let us take any point P on this circle and suppose this point is z0. So we can write z0 to the power 8 minus 2 to the power 8, and this is z0 minus 2, z0 minus 2 alpha up to z0 minus 2 alpha to the power 7. And if we take its mod, so we can write mod of z to the power 8 minus 2 to the power 8. It will be mod of z0 minus 2 into mod of z0 minus 2 alpha up to mod of z0 minus 2 alpha to the power 7. Now this is distance between two complex numbers. So this is basically PA1, this is PA2, and this is PA8. So we can write PA1 into PA2 up to PA8, and that will be equal to z to the power 8 minus 2 to the power 8. Now since this P, it lies on this circle, so we can write this z0 as sum 2 e to the power iota theta. So it will be 2 to the power 8 plus e to the power iota 8 theta minus 2 to the power 8. Now we'll take 2 to the power 8 common. So it will be this 2 to the power 8 e to the power iota 8 theta minus 1. Now what we'll do is we'll try and find the maximum value of this expression on the right hand side so that we'll get the maximum value of this expression on the left hand side. Now here what we'll do is we'll take e to the power iota 4 theta common. So we can write 2 to the power 8 mod of e to the power iota 4 theta, and here will be e to the power iota 4 theta minus e to the power minus iota 4 theta. Now we know that mod of z1 into z2 is mod of z1 into mod of z2. So we can write this as 2 to the power 8 mod of e to the power iota 4 theta into mod of e to the power iota 4 theta minus e to the power minus iota 4 theta. Now this is cos theta plus iota sin theta minus cos theta minus iota sin theta. Here cos theta will cancel. So we can write 2 to the power 8, and here modulus is 1. So it will be this 1, and here will be 2 iota sine 4 theta. Now mod of iota is 1. So we can write this as 2 to the power 9 sine 4 theta. Now maximum value of sine is 1. So it will always be less than 2 to the power 9, which is 512. So the maximum value of this product PA1, PA2, PA8 is 512. So the maximum value of this product PA1 into PA2 up to PA8 will be 512, and that is the answer to this question. Now the question is, we are given this matrix R where A, B, C, D, they belong to this set containing 0, 3, 5, 7, 11, 13, 17 and 19, which is 8 numbers. Now it says, then the number of invertible matrices in R is. Now rather than finding number of invertible, what we'll do is we'll find number of non-invertible and then we'll subtract it from the total number of matrices that can be formed. So first we'll find total number of matrices in R. So total number of matrices in R, it is given by, now for A we have 8 choices, for B we have 8 choices, so it will be 8 into 8 into 8 into 8 4 times, there will be 8 to the power 4 or 2 to the power 12. Now 2 to the power 10 is 1024 into 4, so it is 4096. So total number of matrices that can be formed is 4096. Now we need to find all those matrices which are non-invertible. So we'll find number of non-invertible matrices. And for that we need to find determinant of R. Determinant of R will be this A, 3, B, C, 2, D, and this is 0, 5, 0, and there will be minus 5, AD, minus BC. Now it will be non-invertible if AD minus BC is 0. So we have to find how many cases are possible in which AD is equal to BC. Now we'll consider two separate cases. Case 1, when AD equals BC and it is equal to 0. And the second case where AD is equal to BC but they are non-zero. Now in this, at least one of A or D is 0. So this is at least one of A or D and at least one of B or C is 0. Using inclusion exclusion. Now if A is 0, then we can choose D in 8 ways, plus if D is 0, we can choose A in 8 ways, and then minus that case where both of them they are 0. So this is 15, and the same way for B and C also we'll have 15 cases. So total number of such matrices will be 15 into 15 and there will be 225. So that's our first case. Now we'll come to the second case where none of them is 0. So that means now we have to choose the numbers from remaining 7 numbers. Now here also we have two cases. Case 1, if A is equal to D, and this second case when A is unequal to D. Now if A is equal to D, and since all the numbers given are prime numbers, that means they should also be equal to B and C. So in this case we'll have total 7 cases. Now in the second case, when A is unequal to D, from these 7 numbers we can choose any 2 numbers, and it can be done in 7C2, and we can arrange them in factorial 2 ways, and those 2 chosen numbers must also be distributed among B and C. So multiplied with factorial 2. Now this is 7, 6, 21. 21 into 4, 84. So total number of non-invertible matrices, it will be 225 plus 7 plus 84, and that will be 316. Now we have to find number of matrices invertible. So number of matrices which are invertible will be given by this total number 4096 minus all those matrices which are singular, and there are 316 such matrices, and this number, it comes out to 3780, and that is the answer to this question. Now the question is, let C1 be a circle of radius 1 with center at origin and C2 be a circle of radius r with center at A 4, 1. So we have two circles. One of them center is at origin and radius 1 unit, and that's your circle C1, and equation of C1 will be x square plus y square minus 1 equals 0, and then we have another circle whose center is at 4, 1 and whose radius is r, and the center is A. So radius of this circle, it is r. So equation of C2 will be x minus 4 square plus y minus 1 square, and that will be equal to r square, or we can write x square plus y square minus 8x minus 2y plus 17 minus r square equals 0. Now it says two distinct common tangents PQ and ST of C1 and C2 are drawn. So we have drawn two distinct tangents, and let us assume we are taking direct common tangents. So this is P and this is Q, this is S and this is T. Now it says midpoints of line segments PQ and ST are joined to form a line which meets the x-axis at point P. So if we want to take their midpoints and we're going to join them. So suppose this is M1 and this is M2. They intersect x-axis at this point B such that AB is root 5. So this distance is under root 5. Now since this B, it lies on x-axis, let this point be h, 0. So this AB will be under root of h minus 4 square plus 1, and this is equal to under root 5, and we square it, we get h minus 4 whole square, and this is equal to 4, or h minus 4 is plus or minus 2, and since we need this h between the two centers, we'll take this plus sign. So value of h is 2. So this point B, it is 2, 0. So coordinate of this point B, it is at 2, 0. That says find the value of r square. Now since M1 is midpoint of PQ, that means this distance and this distance, it is same. So power of point from M1 to the two circles is same. And the same way, power of points from M2 to the two circles is same. That means these points M1, M2, they lie on radical axis. So basically, this line joining M1, M2 is nothing but radical axis. And this radical axis, it passes through this point 2, 0. So we have to find this radical axis. Now radical axis is basically C2 minus C1. So if we put x square minus y square as 1, we'll get this equation as 8x plus 2y, and it will be equal to 18 minus r square, and this radical axis will pass through this point B, which is 2, 0. So this is 16, and this is equal to 18 minus r square. So value of r square is simply 2. And that is the answer to this question. Now the question is, consider an obtuse angle triangle ABC in which difference between the largest and the smallest angle is pi by 2 and whose sides are in AP. Suppose that vertices of triangle B on a circle of radius 1. So essentially we have this obtuse angle triangle. Suppose this is A, B and C. This side is A, this is B, and this is C. Now let this C be the smallest side and this A be the largest side. So twice B equals A plus C. Now suppose the smallest angle is theta. So this is theta. Then the largest angle will be pi by 2 plus theta. And this angle B, it will be pi by 2 minus 2 theta. So there will be pi by 2 minus 2 theta. And vertices of this triangle lie on a circle of radius 1. So that means its circumradius is 1. Now using sine rule, we can write 2 and B is 2r sine B. So 2 sine B equals sine A plus sine C. Now this is 2 sine and B is pi by 2 minus 2 theta. Sine A is sine pi by 2 plus theta, and sine C is sine theta. Now this is 2 sine 90 minus theta is cos theta. So there will be 2 cos 2 theta, and this is cos theta plus sine theta, where theta is an acute angle. Now we can write cos 2 theta as cos square theta minus sine square theta, and this is cos theta plus sine theta. Now cos theta plus sine theta will be positive, so we can cancel that. So from here we'll get this condition that cos theta minus sine theta, and this value, it will be 1 by 2. In this question we are supposed to find area of this triangle ABC. Now area of this triangle, we are going to use delta because we have already used A. So let us say this area is delta and this area is ABC upon 4R. Now we can change ABC using sine rule. So there will be 2R sine A, 2R sine B, 2R sine C. So there will be 8R cube sine A into sine B into sine C upon 4R. Now R is 1 and this is 2. So area of this triangle will be 2 sine A, and it will be this sine pi by 2 plus theta. Sine B is sine pi by 2 minus 2 theta, and it will be this sine theta. So this area, it will be 2. Now this is cos theta and sine theta. So it will be 2 sine theta cos theta, and here it will be sine pi by 2 minus 2 theta is cos 2 theta. So area of this triangle will be sine 2 theta into cos 2 theta. Now we need to find the value of sine 2 theta and cos 2 theta. So what we'll do is we'll square this. We'll write 1 minus sine 2 theta. It is 1 by 4. So from here we can write sine 2 theta will be simply 3 by 4. And if sine 2 theta is 3 by 4, then cos 2 theta will be simply 1 minus 9 by 16. So there will be under root 7 by 4. So area of this triangle, it will be sine 2 theta, which is 3 by 4, and this is root 7 by 4. So this is 3 root 7 by 16, and that's your delta. Now we need to find the value of 64 delta square. So we need to find the value of 64 delta whole square. So it will be this 64 and delta is 3 root 7 by 16 whole square. So this is 144 into 7, and it will be 1008. So in this case, value of 64a square will be 1008. Now 15th part is find the in radius of this triangle ABC. Now we know that R is delta upon S. Now delta we have already figured out. This delta is 3 root 7 by 16. We just need to find the value of S, and S is semi-perimeter. So this S, it is A plus B plus C by 2. Now since ABC are in AP, so A plus C is 2B. So there will be simply 3 by 2B, and this is 3 by 2, and this is 2R sine B. Now R is 1, so it will be this 3 sine. Now angle B, what is angle B? Angle B is pi by 2 minus 2 theta. So there will be sine pi by 2 minus 2 theta. So this is 3 cos 2 theta, and cos 2 theta is root 7 by 4. So value of S is 3 under root 7 by 4. So now we have delta and we also have S. We just need to find the value of R. R is delta upon S. Now delta is 3 root 7 by 16, and S is 3 root 7 by 4. I'll cancel. So value of R is 1 by 4 or 0.25. So in this case, in radius of this triangle ABC, it is 1 by 4. And that is the answer to this question. Now here the question is, consider 6 cross 6 square in this figure. Let A1, A2, A49 be points of intersection, dots in the same order. We say AI and AJ are friends if they are adjacent along a row or along a column, assuming that each point AI has an equal chance of being chosen. Now this question is, let Pi be the probability that randomly chosen point I has many friends. So I can take the value 0, 1, 2, 3, 4, etc. Let X be random variable such that for I equals 0, 1, 2, 3, 4, probability of X equals I is Pi. Then we need to find 7 into expectation of X. So basically it's a problem of probability distribution. Here the first thing that we need to find is, what are the possible values of a random variable X. See, the minimum number of neighbors that any point has are the corner points, and for every corner point we have 2 friends. So minimum value of X is 2, And then if we choose any point on the edge other from corner, in that case it'll have 3 friends. And for any point inside this grid, it'll have 4 friends. So there are only 3 values possible for this random variable. So value of x can be 2, 3 and 4. So we need to write this probability distribution. So this is x and that's your corresponding probability. X can take the value 2, 3 and 4. Now, what is the probability that a point chosen will have 2 friends? Now, a point chosen will have 2 friends if it is any of these 4 corner points. So this probability will be simply 4 by 49. Now, this probability that it will have 3 friends, it will have 3 friends if it lies along any edge other than the corner point. So we have 5 points here, so there will be 5 into 4, 20. So this probability will be simply 20 by 49, and then there will be points with 4 neighbors. So all the points which are inside, so we'll have 5 into 5, 25. 25 such points. This probability will be 25 by 49. And if we calculate the sum of all probabilities, this is 1. So this is our probability distribution. Now we need to find expectation of x. Now expectation of x is summation xi into pxi. So that is 8 plus 60 plus 100 divided by 49, and this is 168 divided by 49. Now this is divisible by 7. So this is 7 and this is 24. So we can write 7ex, it is equal to 24. So the value of 7 times expectation of x is 24, and this is the answer of question 16. So that's a question number 16. Now for question number 17, it says 2 distinct points are chosen randomly out of these points A1, A2 and A49. Let P be the probability that they are friends. What is the value of 7P? Now, total number of ways or total number of elements in sample space, it is simply 49C2, and there will be 49 into 48 divided by 2. So there will be 49 into 24. Now we need to find the probability that both of them, they are friends. Now they'll be friends if they are adjacent. So we need to choose any 2 consecutive points. So we can choose 2 consecutive points either on a column, or we can choose them along a row. Now if we look at this first line, here we have 7 points, and from these 7 points, if we have to choose 2 consecutive points, it can be done in 7 minus 2 plus 1 ways. So this is consecutive selection, and we have 1, 2, 3, 4, 5, 6, 7 columns. So it will be into 7 plus, in the same way we can choose these points along the row. So it will be the same case. So what we'll do is, rather than adding, multiply it with 2. So this value, it will be 84. So this required probability P will be 84 upon 49 into 24. Now this is 7 and this is 2. So this probability is 1 by 14. Now we need to find the value of 7p. So value of 7p is 1 by 2 or 0.5. So this required probability is 1 by 2 and that is the answer to this question.